A photographer took 12 different photographs. There are three sunsets. So we have three sunset, four ocean, and then five mountain. So the photographs are arranged in a line on a wall. Find the number of possible arrangement if the first photograph is of the sunset. So first is the sunset. Sunset we have three. And then N last one, N with the ocean. Ocean we have four here. So out of 12 minus 2, then we have 10 here. This is 10p 10, 10p 10. So we have the 3 times 10 p10 and then times 4. So this will be the answer. Okay. 43545600. Okay. Find the number of possible arrangement if all the photographs of mountain are next to each other. So all the mountain next to each other. Okay, so this one as one. Okay, one. And then this we have one, two, three, four. This is one, two, three. So we will become 8 here. 8 P8. And then this one we have the 5 factorial. Okay. So this one we have the 5p5. So we have the 8p8 times 5p5. So this will be the answer. So this is 4838400. Okay. Yes. B. Three of the photographers are select for competition. Okay. So uh three select for competition. And then number one, okay, find the number of different possible solution if no sunset. No sunset. So we have 9 here. So n equal to 4 plus 5, 9 here. So we have to choose 3. So 9C3 here. So this is 9C3, then it's 84. Okay. Next, find the number of different possible selection if one photograph of each type is chosen. So 3C1, 4C1, 5C1, then it's 3 times 4 times 5, 60. Okay. Given the 45 times NC4 equal to n plus 1 times the n plus 1 C5. So we know that the NCR here is the n factorial, r factorial, n minus r factorial. Okay, so for this question number 2 here, we have the 45 times n factorial, 4 factorial, n minus 4 factorial equal to n plus 1 multiplied with the n plus 1 factorial and then 5 factorial, n plus 1 minus 5 factorial. So we have the 45 times 5 factorial over 4 factorial equal to the n plus 1 times the n plus 1 factorial over n minus 4 factorial and then times the n minus 4 factorial over n factorial. So this one, okay, is this. And then we move the. Okay, so we know that the 5 factorial is 5 times 4 factorial, is 5 times 4 times 3 factorial, and so on. And we have the n plus 1 factorial. I also can write as n plus 1 times the n factorial. So 45 times 5 times 4 factorial over 4 factorial equal to n plus 1 times the n plus 1 times the n factorial over n factorial. These two cancel. So cancel, cancel. So we have the 45 times 5 is the 225 is equal to the m plus 1 square. So m plus 1 is the plus minus square root 225. So square root answer is 15. So m plus 1 equal to plus minus 15. So n will be 15 minus 1, 14. And then n equal to negative 16. This one rejected. Okay, because the n must greater than 0. So 14, we want to check whether it's correct or not. 45 times 14 C 4. Then we will have 45045. Okay. And then the uh for the 14, then plus 1 is 15 times 15 C5, then 45045 as well. So the left hand side equal to the right hand side. When we substitute the answer 14, then it's correct. So this is the left hand side, this is the right hand side. So correct. So my answer is correct. So question number 3, the number of combination of n item take 3. N item take 3 is the NCR is equal to 92n. So n factorial 3 factorial n minus 3 factorial equal to 92n. So we have the n times n minus 1 times n minus 2 times n minus 3 factorial over n minus 3 factorial is 92n times 3 factorial. So this can be cancelled, and then the n and n here can be cancelled. Okay, because n not equal to 0, so I can just cancel. So 92 times 3 factorial is 552. So 552 equal to the n square minus 2n minus n plus 2. So n square minus 3n minus 550 equal to 0. So 550 is the 25, 22. So we have the n 25, 22. So minus 25 plus 22. So n equal to 25, n equal to negative 22. So this one is rejected. So we have 25. So 25C3, okay, 25C3 is 2300. And then 92 times 25 is 2003 as well. So the left hand side equal to the right hand side. So the answer that I get is correct. Okay. Okay. Number 4, the number of combination of n take 3, nc3 is 6 times n take 2, nc2. Find the value of constant n. So we have the n factorial over 3 factorial n minus 3 factorial equal to 6 times the n factorial 2 factorial n minus 2 factorial. So this can be cancelled and move this here. Then we have the n minus 2 factorial over n minus 3 factorial equal to 3 times 6 times 3 factorial over 2 factorial. So n minus 2 times n minus 3 factorial over n minus 3 factorial equal to 6 times 3 times 2 factorial over 2 factorial. So cancel. So we have the n minus 2 equal to 18, n equal to 20. Then